When you think of a process engineer, what comes to mind? Probably someone in a hard hat, right? Constantly running around the factory floor, putting out fires. The hero firefighter of manufacturing, just racing from one crisis to the next. But that whole stereotype, it's getting a serious upgrade. So let's take a look at the new playbook for the modern process engineer. Honestly, a way better analogy for today's process engineer, and really the core of this whole explainer, comes from a Reddit user, of all places. They said the engineer is the quarterback. See, they're not just reacting to chaos anymore. They are the strategic hub of the whole operation, calling the plays for the entire team. So what does it actually mean to be the quarterback of a manufacturing process? Well, it means you're that crucial link, the one person holding it all together. The process engineer is the one who lays out the game plan for everybody, from the mechanical engineers designing the pipes to the electrical teams wiring up the control valves. They make sure every single piece of this massive, complex machine works together to, score that touchdown. And this quarterback, they don't just live on the field. The job is a true hybrid role. A process controls engineer spends about half their time in the office, doing design work and in meetings, but the other half is spent right in the action, either in the high-tech control room or out there on the manufacturing floor. Yeah, it is a super demanding position. In fact, according to one process engineer with 26 years of experience at Torrey Plastics, the entire job really just boils down to overcoming three massive core challenges. These are like the defensive lines that every single process quarterback has to find a way to break through, day in and day out. All right, challenge number one, it's all about the people. Manufacturing is a team sport that runs 24/7, and the stakes are incredibly high. So trying to keep these huge, diverse teams perfectly aligned across different shifts, it's like a giant communication puzzle where the pieces are always moving. And the stakes here, well, they could not be higher. I mean, look at this contrast. On the left, you've got effective communication. It's clear, face-to-face focused. And on the right, you see the absolutely catastrophic result when that communication breaks down. The consequences aren't just about lost money. They can be about life and death. And look, this isn't some textbook theory. The investigation into the Piper Alpha disaster, which tragically killed 167 workers, found that critical information about a safety valve that had been removed was never passed on during the shift change. And it's the same story for the Texas City refinery explosion, a direct result of supervisors and operators failing to communicate vital info. So how do you solve this? Well, the industry has a very clear, disciplined playbook. An effective handover is way more than just a quick chat. It's a formal three-step process. First, the outgoing shift has to prepare all the info. Second, there's a real two-way conversation, not just a logbook left on a desk. And finally, the incoming team has to cross-check all that info as they take over. Okay, let's talk about the second big hurdle, the knowledge gap. It used to be that engineers and operators would spend their entire careers at one company, becoming these walking libraries of process knowledge. But today, people change jobs a lot more, and when an experienced engineer walks out the door to retire, all that priceless knowledge can walk right out with them. The old-school solution to this was a system called Process Control Management, or PCM. You can think of it like the team's official playbook, a huge system for documenting everything from people's skills to the condition of the equipment. The idea was to create a library so that a newcomer could get up to speed. It's really important, but man, it can be slow and clunky. But the real game changer today? It's data. Instead of expecting a new engineer to basically memorize a massive encyclopedia, modern tools let them instantly pull up and analyze years of historical data. This means a less experienced engineer can troubleshoot a problem with the insight of a 20-year veteran, just by seeing how the team handled it before. And that huge amount of data, well, that leads us straight into our third and honestly most modern challenge. See, the problem today isn't a lack of information, it's being completely and totally overwhelmed by it. Factories have digitized pretty much everything, but all that data can quickly turn into a deluge of noise. This slide really shows the huge shift. The old way was just a nightmare. You'd be digging through endless email chains, finding reports that contradicted each other, and trying to get data out of these siloed historian systems, which are basically these giant, clunky databases for industrial data. The new way is all about creating a single source of truth, a system that makes data available to every single engineer who needs it right away. So you've solved the data access problem. Great. You've got this digital goldmine at your fingertips. Now what? What's the point of it all? Well, it all comes down to answering two deceptively simple questions that every single process engineer on the floor needs to know, like right now. The very first question is this normal? When a sensor reading suddenly changes or pressure starts to fluctuate, the absolute first thing an engineer has to figure out is whether this is just a normal little variation or if it's the first warning sign of a major problem. And the second, just as critical, question, has this happened before? Because if it has, the solution is probably buried somewhere in all that historical data. Before these modern tools, just answering those two simple questions could take hours, sometimes even days, of painful digging. Now it can take seconds. Okay, so let's put all this theory into practice. We're going to look at a real-world example from Torrey Plastics that shows exactly how these next-gen analytics tools help their engineers beat all three challenges and shift from playing defense to playing offense. So here was the situation they were dealing with. They had this nagging, recurring issue in their raw material scaling process. Little delays in preparing the raw materials were just cascading and causing major headaches down the line, eventually leading to really expensive production downtime. And this is what that headache really looked like in practice. A small delay over here would force them to make process changes they didn't want to make. That would then lead to them having to reduce the line speed, and in the worst-case scenario, the whole production line would just have to shut down. This was that reactive firefighting mode. So the solution was to completely flip the script. Instead of just reacting to the shutdown after it happened, they used self-service analytics to monitor the process proactively. They decided to get out ahead of the problem. And the technical tool they used was actually pretty straightforward. They just created what's called an if-else formula tag in their analytics software. It's basic logic. If the production rate is faster than the prep rate, then send an alert. That's it. This simple little rule let them keep a constant eye on the balance between these two critical numbers. And boom, here's the payoff. The very moment the production rate started to creep past the prep rate, the system automatically sent an alert. That gave the production team time to investigate and take action before it became a full-blown crisis. The problem was solved before it even really became a problem. And this right here brings us right back to where we started. With these kinds of tools, the process engineer's job fundamentally changes. They're no longer the reactive firefighter just rushing to the next emergency. They become a proactive process optimizer, the strategic quarterback who sees the whole field and makes adjustments to make sure the team keeps on winning. So it really makes you wonder, right? As factories get smarter and smarter and analytics get more and more powerful, the question isn't if the process will be optimized, but who, or maybe what, will be calling the plays. Will the next quarterback be a human, or will it be an AI?